Hey, it's me, Tarek here, and today I am going to be talking about a very special body system. A body system that is very important to us, and it is actually really big. Like, if we took the circulatory system and we actually applied it to the concept of a road, it would be about 96,000 kilometers, stretching and supplying blood to about 60 trillion cells. The circulatory system is the main way it transports things throughout our entire body is through our precious red liquid, and that is blood. Blood is so important because blood helps transport all our material. Not only that, provides oxygen to almost all our tissues in our body. Every tissue in our body almost needs blood in order to function. Our blood comes in two different forms. It comes in deoxygenated form and it also comes in oxygenated form. Deoxygenated means no oxygen in that kind of blood. And usually on diagrams of the circulatory system or the heart, the deoxygenated blood is in the color blue. Now, in real life, the actual deoxygenated blood is more of a darker purple kind of color, but on diagrams, it's just a nice good old blue. And then the red blood is the oxygenated blood. And that's how actually oxygenated blood would be. It would be super red, super saturated, and that's the blood that our tissue needs. Our tissues need oxygenated blood. And the job of our circulatory system is to create oxygenated blood and distribute it to all our tissues in our body. And now let's get into the king or the queen of the circulatory system, and that is the heart. The heart is covered with a membrane called pericardium. Pericardium prevents friction with the heart and other organs in the body. The heart is always pumping blood. It pumps 5 liters of blood every 5 minutes. And the heart is always pumping, it's always moving. So when the heart moves, it's obviously going to touch other organs in the body. And we don't want that to happen. The heart cannot provide friction with other organs. Friction means when you do this. So when you do this, you're providing friction. And as you notice, my hands start to get hot when you're doing this. And since the heart is always pumping blood every 5 minutes, 5 liters of blood is pumping from your heart. And the heart is always moving. So when it's always moving, it's always going to be like this with other organs in our body. And we cannot have that happen. It will be overheated. The blood will be having too much heat to deal with. So the job of the pericardium is to prevent friction with other organs. Now let's get into the inside of the heart. The inside of the heart has 4 different chambers. It has 2 upper chambers and it also has 2 lower chambers. These chambers are separated in half by this thing called the septum. The septum is a very, very important part of the heart because it separates the deoxygenated blood and the oxygenated blood, preventing them from mixing. It's so important that the blood remains separated in order for it to be pumped to our tissues in proper form. Now let's get into the process of how the heart makes oxygenated blood. How it takes our blue blood and makes it all nice and red. So let's get into it. The first part of the process is bringing deoxygenated blood to the heart in order for it to become oxygenated. And as you see in the blue side of the diagram, the side that's blue on the right side, that's where the deoxygenated blood goes. So the deoxygenated blood comes from our tissues, our organ systems, through the Vena Cavas. The Vena Cavas, think about them as really big veins. They're really huge veins that bring deoxygenated blood back to the heart. And there's 2 different kinds of Vena Cavas. There's the superior vena cava and there's the inferior vena cava. The superior vena cava, think about the word superior, meaning on top, meaning higher. So the superior vena cava brings deoxygenated blood from our upper tissues, like our brain, our shoulders, our arms, our muscles, all rely on the superior vena cava in order to bring deoxygenated blood back to the heart. And then we have the inferior vena cava, and the inferior vena cava is the complete opposite. It lies on the bottom side of the heart. And the inferior vena cava brings deoxygenated blood from the bottom tissues, like our legs, our feet, our kidneys, all rely on the inferior vena cava to bring deoxygenated blood back to the heart. Once the blood is done with the vena cavas, it enters through to the right atrium. This is the first upper chamber of the heart that the deoxygenated blood goes through. Once blood is done going through the right atrium, it goes through the tricupsoid valve. This is the valve it needs to go through in order to get to the right ventricle, which is the lower chamber of the heart. Keep in mind, the right side is where deoxygenated blood is, where all the blue blood is, and the left side is where oxygenated blood is. Once it's done going through the right ventricle, it's time for the deoxygenated blood to become oxygenated blood. And now, once it's finished its journey through the right ventricle, then it's going to go through the pulmonary valve. And that pulmonary valve opens up and the deoxygenated blood goes to the pulmonary artery. So once our blood goes through the pulmonary artery, it goes away from our heart. And then it goes into the lungs. The lungs is the place where blood is going to be exchanged, where our deoxygenated blood is going to be exchanged for oxygenated. And once our blood travels through our lungs, it goes to the alveoli. The alveoli is one of the most important organs in our body, because the alveoli is what makes this whole exchange possible. The oxygenated blood goes through a very important tissue, and that is the pulmonary veins. And these veins bring the oxygenated blood back to the heart, to the left atrium. And once it's in the left atrium, so now the blood is on the left side of the diagram, on the red side. Once it's in the left atrium, it goes through the mitral valve. And the mitral valve takes that oxygenated blood to the left ventricle. Once it's done through the left ventricle, it goes through the aortic valve. And the aortic valve takes that good old oxygenated blood and takes it to the aorta. The aorta is the biggest artery in the body. The aorta is the biggest artery and the most important artery in our entire body. As you can see, the aorta is really big, and it makes up a huge part of the heart because the aorta is the tissue that's responsible for getting that oxygenated blood to our organs in our body. All our tissues receive oxygenated blood, and the process starts over. And this process always reoccurs in a cycle, again and again and again. Every single day, every single second, this process is occurring. And this process is so important for us to be alive. Any malfunctioning in this process alone can be detrimental to our health. It's very important for this process to continue to function in order for us to live. That's it for the circulatory system. Thanks for watching.